All right, can you all hear me okay? All right. So I just noticed a mistake in my home in the WebAssign, and I think it's because of the issue I had at the beginning of the semester. The one problem that I had created, I thought I added to this assignment, and it's not there. So I just sent you the practice exam. I will send you one or two more problems. So that problem I did in class today, the complicated one, for some reason is not in this homework assignment. In fact, when I printed it out, it was there. I'm not sure what happened. So that complicated one I don't see in the assignment. So I think when I switched WebAssign in the beginning of the semester, I forgot about this homework assignment. So I'll send you the problem along with the solution so you can take a look at it. Okay? And it'd be a good practice. For this chapter, I don't have good polling questions, so I can't really do a poll. I've even looked at it. There's really not good questions for this chapter. So I think what I'll do is answer questions you may have on the homework. By the way, this is the last week that we're doing the discussion board. I think everyone's done a question twice, and so we're not going to be doing a discussion board for the rest of the semester. So we're pretty much done. So it's basically all your assessments are done for this class. Okay. Do you have questions on the homework? Problem 3B? Okay. All right. So, yeah, you're right. That is a phasor problem. So, let me draw the picture. So in the first one, they're kind of essentially hooked up in series. Oops. Although you might not be able to see this very well, I'm just going to show it anyway. But that's not what I wanted to do, sorry. All right, I'm going to stop here. Okay, let me switch. Okay, that's better. So, we're going to treat the voltages as two phasors. And in part A, these are power supplies that are connected in series. Because when you connect something in series, you go positive to negative, negative to positive, right? It's just like on the batteries. So the phase shift between them is, we'll call it phi, okay? The angle between the two phasors is phi. So basically, when you talk about the angle between two vectors, you got to put their tails together. Now here's vector 1, and here's vector 2. And that's phi. This is when I connect them. So this is for part A. if I want to add V1 to V2, obviously I got to use the head to tail method. So here's V1. I'm going to slide this over so I use the head to tail method. This angle is phi, so this angle is 180 minus phi. And so the resultant is that, which, how can I obtain the resultant now? Right, I know this magnitude, I know this magnitude, and I know the angle between those two vectors. Yeah, you use trig, okay. But it's a law of cosines, right? You just use the law of cosines. Okay. You don't have to use the law of cosines, but that's the fastest way to get to the response. Now, when in the other case, this is flipped over in the other direction. So when you do it negative to negative, so this vector is like this. And so then this will be phi now. Okay, and this is 180 minus phi. Well, I gotta be careful because this is 180 minus phi. And this is phi. And then you use the law of cosines. Okay. And you might say, well, isn't that 180 degrees? Shouldn't I flip this by 180 degrees? And you're right, but I get the same result. Okay. Yeah, it's really a matter of understanding what that means. Okay. And then once you understand what it means, then you're just adding vectors using law of cosines. And the book doesn't talk about that, but I mean, it's important. Well, what happens if you have two power supplies that are not in phase? What do you do? Okay. Other questions? No other questions on the assignment? You haven't gotten that far yet, huh? I will add a date to this. I apologize, I haven't done that yet. I'll add the date to this assignment. But please, yeah, work on it right away. This is a fairly long assignment. I know it's a holiday tomorrow. So, okay. And it's true that some of these are straightforward too. I mean, I'm trying to think. The last one you should be able to do now because I did it in class essentially. I should even show you a demo in class. Do you have any questions on anything then? No questions. Nobody has any questions. This will be a short meeting. Okay, so next Wednesday. Okay. Yeah, can you put your name on the motor? That identifies the motor. So have you all got the motor pretty much working, or are there problems with the motor still? What you should find is that any adjustments you have to make are small details. That's part of this exercise is focusing on details to make things work better. Okay. If this was done on campus, you would be coming into the lab, and we would use our big power supplies, and you would make adjustments. Unfortunately, we're not in that situation. That's why, for example, I set the limit. I set it to 3 volts instead of 2. If you want to get it run to 2 volts, it takes a little bit more doing. But we had people last semester get those motors running on 1 battery. So if you want to try, if you've run it at 3 volts, you should see if you can run those motors on 1 volt, 1.5 volts. The record is like 0.8 or something. Somebody, I forgot, one semester had like 0.8 volt, had it run at 0.8 volts, yeah. But I had first last semester get it running on 1 battery. It can be done. So I don't know if you guys have tried it. And maybe I should have encouraged you guys more to try to see if we get it down to 1.5 volts, but that's okay. If you got 3 volts, that's fine. Okay. And we can only use discrete values, 1.5, 3, 4.5, etc., because of these cell batteries. We did have one person use the power supply that came with the kit, and I was surprised that it worked. But I guess you're not drawing a lot of current in that case. But I've had some semesters where students would have to put 9 volts on the motor, and we're drawing like 8 or 9 amps. That little charger wouldn't work. So you use that power supply and it worked fine, huh? Okay. So you probably weren't drawing too much current. Yeah, that's the thing, Daniel. The brushes is the hardest part, I think. That's really, I think, the hardest part of and right, it's a small detail. Just making sure you get good contact. If you went out and bought that tape, some people bought tape, and that makes it a little bit easier. That's strange. If you unplug it and plug it back in, the motor won't work anymore, Daniel? Did you measure the voltage from the supply? Yeah, you want to make sure that it's still working. So if you can get it working with that supply, then it should work with the 2 batteries. Okay, so you did get it to work again, okay, so that means your supply is okay. But a lot of it's just having good contacts with the brushes. You'll find that if you don't use these for a year, they won't work because the copper gets oxidized. Okay, let me go one question at a time here. So brushes make contact with the armature when it's vertical. When the armature is vertical. In other words, here's the magnet. Here's the armature. Let me draw the coil. The normal is this way, and the magnetic field is approximately that way. It's not exact, okay? But you want current flowing like this, right? You want current there. So yeah, you want, so Aaron, you mean the brushes make contact with the commutator, right? Yeah, so the brushes, you want the brushes to make contact with the commutator when it's like this. Okay. When it's horizontal, you don't, because the torque is going to be zero anyway. When it's like this, the torque will be zero anyway. So you don't want. I mean, that's where the current reverses direction is when it's like this. Does that make sense? Yeah, it does. As it rotates, there's a place where it reverses, but we're assuming you're always making contact except when it splits, and when it meets that gap. So let me get Daniel's question. Can we use aluminum foil as brushes? You can. It's just that aluminum foil is kind of thin, though. I mean, you'd probably have to try the heavy-duty one. Oh, you mean as brushes? I would still use the heavy-duty one. But it just bends a lot, though. I mean, you can try it. You're free to try whatever you want. I mean, I'm worried about it tearing stuff, but if you try that, because aluminum is a good conductor, I would use the heavy-duty aluminum foil, a thick one. Don't use a thin one, because that stuff rips apart real easy. Oh, the split ring. Yeah, same thing. I would use the heavy-duty one. For the commutator, if it heavy-duty, you can try. I mean, I can't. It's been a while, but I think I've had students try it. Because if you can't get the copper tape, you can try the aluminum foil. But again, you want to use the heavy one. And you can maybe look at something that has some adhesive on it. Let me check real quick. Yeah. One thing is the tape for the dryer. Right, because that has adhesive on it. Foil tape is available at Lowe's, so maybe that would be a better choice. Of course, you're gonna have to pay more than buying aluminum foil, but at least it'll stick. You just copper is the best conductor. But I checked because somebody asked a question earlier. Lowe's has copper tape and it has a metal foil tape. You can try those. But the only thing is you got to buy a whole roll. And I'm looking at Lowe's website right now. They have metal repair tape that's like $7 or $8. And I would assume it's pretty conductive. So, is that okay, Daniel? Did that answer your question? Okay. Other questions? No more questions? You folks feel comfortable drawing phasor diagrams? I mean, you should be able to do phasor diagrams for RL, RC, RLC. I mean, should be able to draw those. And I'll send you that one problem I started in class today. I'll send you that as a practice problem. That was a harder problem, but at least you'll get a better idea of how phasors work. No more questions? Okay, so some of the problems later on in the assignment get a little bit mathematical. Let me just mention one of them. Number 15. And it's really part C. And I'm going to create a video for this. I told the second lab group, I'm going to have to create a video because we're behind. Next Wednesday, I'm not going to lecture on the LRC lab. I'm just going to create a video regarding the equation to solve. Okay. So in problem 15, the last part, we talked about power as a function of frequency, power as a function of omega in an LRC circuit. We know that the graph will look like this. Here's the peak. And here it is, half the peak. So let's call this P max. This is 1/2 P max. And you see that there's two values at which this occurs. One over here, I'll call omega 1, and one over here called omega 2. Okay? Then delta omega is the difference in these two values. What is the equation for power? It was V sub m squared, omega squared, over, I normally don't remember this, but because we're in this chapter, I remember it. So that's what the power equation looks like. And you can show that the delta omega, omega naught over delta omega is equal to omega naught L over R. And that's key. That's why they're asking for this. If you take the difference between the two, you'll get omega. So how do I show that? Well, P max occurs when omega equals omega naught. So I plug in omega naught. These two are equal to each other. What does that give me? So I want to look at 1/2 Pmax over Pmax. What is that equal to? Where is this ratio equal to? Isn't it equal to 1/2? Which is also equal to, remember this is at a different frequency. So let me cancel out these guys. This guy's going to come up here. So I end up getting, I'm going to use a different color. I'm worried about a math error somewhere. Let me check something because I'm worried about a math error. Oh, I forgot, you guys, I forgot there's an R here. Okay, I forgot the R here. Okay, so I forgot that R, sorry about that. I was wondering if it wasn't making sense. Yeah, so this squared and these guys cancel, I should get B squared over R. Yeah, I forgot the R squared on top. I should have tried to memorize that equation. It's a hard equation to memorize, sorry. But when I looked at this, it didn't make sense. Okay, so then when I get to this point, I'm going to cross multiply. And then I'm going to move this to the other side. Then I will take the square roots of both sides. And I'm going to say plus or minus. I still got to solve for omega. And notice there's going to be 4 solutions. So let me divide both sides by L. Now let me come up here. By the way, in the lab, you're going to do the same thing except with the current, with the expression for current. Let me bring everything over to one side of the equation. And so now let me solve this using the quadratic formula. So this is positive or negative. There are 4 solutions there. You only keep the positive ones. So let me give you the first one. And then the other solution, I got it right up here. If you take the difference between those two, you'll get that the difference is R over L. Why can't I use the negative solutions? Because they correspond to negative frequencies, which do not make any physical sense. Okay? Now in the lab, you're going to do exactly the same thing, except with the current. And when you do this with the current, there's going to be, there will be a 4 over here. Okay? When you do the current, there'll be a 4 over here, and the root 3 will pop up. And so the difference between the two will have a square root of 3 in there. In the lab, you're going to do this for the current. Does that make sense? So this is related to the quality factor. And that's why we say Q is omega naught over R. Because Q is omega naught over delta omega. Are we okay? You guys still there? Okay. So I think that one would have presented a challenge in the homework, so I figured I'd go through that one, through that problem. Some of the other ones, 16, 17 might take a little bit of work for you there, but there's pretty doable. You have to set up sets of equations, and then you'll get them done. You'll get them done. You should be able to do those. Okay. Really, a lot of the stuff in this chapter is manipulating the same equations. Okay, so if you don't have any other questions, I'm going to stop here and wish you a happy Thanksgiving. All right, take care. So remember, Monday we had the exam. I sent you the sample test. I will send you 1 or 2 more sample questions. They're going to be a little bit harder, but at least hopefully they get you to think about all the concepts together. Okay, one of them is that problem I did in class, which Somehow I didn't put on the homework assignment because of what happened at the beginning of the semester with WebAssign. All right, take care.